The Sun, a massive ball of gas and plasma, sits at the heart of our solar system. Its gravitational pull holds planets, moons, and other celestial bodies in orbit. It accounts for 99.86% of the solar system's total mass. Without the Sun, Earth would be a dark, frozen wasteland. Its energy powers everything from the weather to life itself, making it indispensable. Deep within the Sun, nuclear fusion takes place. At its core, temperatures reach a staggering 15 million degrees Celsius, where hydrogen atoms fuse into helium, releasing immense energy. The energy produced here travels through several layers of the Sun, taking thousands of years to reach the surface, where it radiates out into space, lighting and heating Earth. Despite being classified as a yellow dwarf, the Sun is enormous compared to Earth. It has a diameter of around 1.39 million kilometers, which means 109 Earths could fit side by side across its surface. If you could fill the Sun, it would take about 1.3 million Earths to match its volume, a testament to its colossal size and importance in our solar system. The Sun's surface, or photosphere, is relatively cooler than its core, with temperatures around 5,500 degrees Celsius. Sunspots, dark regions on the Sun, can often be seen from Earth with telescopes. These spots are cooler areas caused by intense magnetic fields and are often associated with powerful solar flares that can eject massive amounts of energy into space. Above the photosphere lies the Sun's atmosphere, where temperatures paradoxically increase. The outermost layer, the corona, can reach temperatures of up to 3 million degrees Celsius, far hotter than the surface. This temperature difference has puzzled scientists for decades, but many believe magnetic energy is the key to this extraordinary phenomenon. The Sun doesn't always behave the same way. It goes through an 11-year cycle of solar activity, alternating between solar minimum and solar maximum. During solar maximum, the Sun produces more sunspots, solar flares, and coronal mass ejections, CMEs. These solar events can impact Earth, sometimes disrupting satellite communications and power grids, especially when large amounts of solar energy hit Earth's magnetosphere. Solar wind, a continuous flow of charged particles from the Sun, streams out through the solar system. When these particles interact with Earth's magnetic field, they create beautiful auroras, such as the northern and southern lights. These lights appear in polar regions, where the particles collide with gases in Earth's atmosphere, producing vibrant displays of color. The Sun's influence extends far beyond Earth. It affects the entire solar system, from the inner rocky planets to the distant gas giants and beyond. Comets, icy remnants from the formation of the solar system, develop bright tails as they approach the Sun. The Sun's heat vaporizes the ice, creating stunning visual phenomena that we can observe from Earth. Though we take the Sun for granted, its energy is a gift that fuels nearly all life on Earth. Plants convert sunlight into energy through photosynthesis, forming the base of the food chain. Solar energy also drives Earth's weather systems, circulating heat through the atmosphere and oceans, ensuring a balanced and habitable climate for all living creatures. The Sun is about halfway through its life. It has been shining for 4.6 billion years and will continue to do so for another 5 billion years. Eventually, it will enter the red giant phase, expanding dramatically as it runs out of hydrogen. During this stage, it may engulf the inner planets, including Earth. After this, the Sun will shed its outer layers, leaving behind a white dwarf, which will cool and fade over billions of years. The sunlight we see today is the result of a long journey. After taking thousands of years to travel from the core to the surface, it then takes just 8 minutes and 20 seconds to reach Earth. This incredible speed of light makes it easy to forget the time it spent moving through the Sun's dense interior before finally escaping into space. The Sun is a dynamic star. Its magnetic field is constantly shifting, which drives much of its activity. This magnetic activity causes sunspots, flares, and CMEs. The Sun's magnetic poles also flip every 11 years, further influencing the cycle of solar activity. This continual change makes the Sun a fascinating object of study for scientists. Solar storms, caused by intense bursts of energy from the Sun, can have significant impacts on Earth. These storms, including solar flares and CMEs, can interfere with radio signals, GPS systems, and even power grids. In 1859, the largest recorded solar storm, known as the Carrington event, caused telegraph systems to fail worldwide and lit up the skies with auroras visible as far south as the Caribbean. The sun's core will eventually run out of fuel, and the hydrogen fusion process will stop. When this happens, the sun will begin to burn helium, causing it to expand into a red giant. During this time, its outer layers will spread out, potentially swallowing Mercury, Venus, and even Earth. This transformation will be slow, unfolding over millions of years, before the sun shrinks into a white dwarf. The sun's energy isn't just essential for life, it's also a potential solution to Earth's growing energy needs. Solar power, harnessed by photovoltaic cells, converts sunlight into electricity. This renewable energy source offers a clean alternative to fossil fuels, and advancements in technology continue to make solar power more efficient and accessible across the globe. Although we often think of the sun as stable and constant, it is a highly dynamic star. Solar flares, sunspots, and storms are just a few examples of the sun's changing nature. As our understanding of the sun improves, so does our ability to predict space weather, helping us protect our planet from its more dangerous outbursts, such as geomagnetic storms. The sun is so vast that it could theoretically hold all the planets in the solar system within it. Despite this, the sun is just one of billions of stars in the Milky Way galaxy. Many of those stars are far larger, while others are much smaller. Our sun is considered a middle-aged star, but its stability has made it ideal for the development of life on Earth. In conclusion, the sun is far more than just a source of light and heat. It's a dynamic star, fueling life on Earth, shaping our solar system, and providing endless opportunities for scientific discovery. As we continue to study the sun, we uncover more mysteries about its influence and role in the universe. If you enjoyed learning about the sun, make sure to subscribe to this channel for more fascinating facts, quizzes, and deep dives into topics like space, science, and geography. Your support helps us bring more educational content your way, and by subscribing, you'll stay updated with our latest videos. Don't forget to leave a comment if you have any questions or suggestions for future topics. We'd love to hear from you. Thanks for watching, and see you in the next video.